Okay, part B. I've brought in the graph, guys, because when you're doing functions and inverse functions, it very much helps if you understand what the graph looks like. So g is defined as this, which is my graph, but only for x is bigger than 3. So it's actually this function here. This is g of x. That's the graph of the function. So I'm going to say, okay, bi. So I'm going to say y is equal to 1 over x squared minus 2x minus 3. Now to get the inverse function, we swap x and y. So because that's what the inverse function is. So I'm going to say x equals 1 over y squared minus 2y minus 3. And my goal is to make y the subject. To make y the subject when I have a quadratic trinomial like this is I have to complete the square. So I'm going to do that in a second. But first I'm going to multiply across by this. So I have y squared minus 2y minus 3 up here. And I'm going to divide by this x. So I'm going to divide by x like that. So that's just rearranging, cross multiplying, however you want to call it. Okay, now I'm going to complete the square. I'll do this quite quickly, guys. If you don't know how to complete the square, go and watch my video on it or find out how to do it. But we essentially half this, makes it 1, square it, subtract 1 and subtract 3, so minus 4. So that's the completed square. If you multiply this out, you get y squared minus 2y plus 1 minus 4, which is this. It's the same thing. And this equals 1 over x. Okay, now I just need to make this the subject. Sorry, make y the subject. So I'm going to add 4. So it's y minus 1 squared equals 1 over x plus 4. 1 over x plus 4. Then I'm going to get the square root of both sides. Now you can start to see maybe, guys, where this is going to come, or how this is going to appear. So we are going to get the square root of both sides. But first, before I do that, let's just say that this is equal to x, common denominator, 1 plus 4x, if I just use a common denominator there. So that means y minus 1 is equal to, okay, y minus 1 is equal to the square root of 1 plus 4x over x, like this. Okay, now note his thing's slightly different here, guys. And by the way, this is plus or minus for now. I'm going to show you why it's going to have to be plus in a second, but let's go over to here. So I'm just going to add the 1. So y is actually equal to this plus 1, or 1 plus this. So 1 plus or minus this. Now what I'm going to do, guys, do you see the way he has 4x squared plus x over x? Well, if I multiply above and below here by x, I am going to get x plus 4x squared. So I multiply everything above here by x and everything below by x, which gives me x squared. Now the reason I'm doing that is only to get it in this form, because now the square root of x squared gives me x at the bottom. So y is equal to 1 plus or minus the square root of x plus 4x squared, which is the same as this, or actually why don't I write it as 4x squared plus x, like he wants it, and over x, like this. Now we have, guys, a situation where y can be 1 plus or minus this. Now note, because the domain of because the domain of G is x is greater than 3, the range of G minus 1 has to be y is greater than 3. So y cannot be negative like it's looking like it's going to be here. Y has to be positive. So this guy, G has x is bigger than 3, and if you look from the graph, this is why I brought in the graph, it's very useful. This guy has x is bigger than 3, and the range is y is bigger than 0. So this guy, and that's actually going to help me answer part II nice and easily, the range is going to be, the domain is going to be x is greater than 0. So I'm going to say here, as y has to be bigger than 3, y is equal to 1 plus or minus the square root, 1 plus, that's the whole point of this. I'm going to get rid of this minus 1 plus the square root of 4x squared plus x over x, which is what he asked to be shown. So I'm going to do QED. Okay, that's part I, and then part II, it says state the domain. So guys, like I've just said, the domain and the range of G means the domain is x is bigger than 0, and the range is y is bigger than 3 for the inverse function. So the domain x is bigger than 0. Okay, that's part B.